All right, this is Arun Gupta from Amazon. I'm here at Devoxx Belgium and very excited to be here with Graeme.
Hi, nice to be here. Thanks very much.
So, Graeme, introduce yourself.
So my name is Graeme Rocher. I'm project lead of a couple of relatively famous open source projects, I guess, Grails and Micronaut. Created of those two and continue to work full-time on open source projects at a fantastic company called Object Computing, who are based out of St. Louis, who offer like full service solutions and so forth. And Micronaut is obviously one of our main focuses right now.
What a joy, huh? We're getting paid for working full-time on open source.
I know. I mean, I'm one of the lucky ones out there. But yeah, I've been doing that for 12 years now, working full-time on open source.
That's pretty amazing.
So I feel privileged to be able to.
I can imagine that.
To contribute
totally
and drive the industry forward and stuff.
Fantastic. So I want to highlight the part. You were the lead for Grails project.
That's right. Yes.
Yeah.
Yes.
So that's your claim to fame, essentially. And now Micronaut is.
Yeah. I mean, recently, the Oracle guys were kind enough to award me the Groundbreaker Award for that work on Grails, and so I think it made a big impact. Pretty innovative at the time. Really changed people's expectations for how rapid application development should be on the JVM. So
I'm
very proud.
I'm very glad to say that you're not a one-trick pony in that sense.
No, I hope I'm not a one-trick pony. We'll see.
And you recently became a Java champion as well.
That's right. Yeah, very privileged again to be nominated to be a Java champion, and it's been It's been under a year since that happened, and it's fantastic to be part of that group.
Many congratulations.
Amazing people.
So many congratulations. All right, so tell us, Grails, a lot of developers, customers know very well.
Yes.
What is Micronaut?
Okay, so Micronaut is a relatively newer project. I guess we launched it in May last year, and it's a new application development framework that uses ahead of time compilation, so intelligent compilation using annotation processes to basically allow you to minimize your Java application's memory footprint and improve startup time, which is becoming a big topic now as we put Java into containers and serverless mode and all that kind of thing. People are looking for solutions where Java applications really need to make big improvements to be more performant, consume less resources, and play well in the containerized world. And Micronaut is trying to address that by taking a different approach to application architecture. So if you look at like traditional frameworks like Spring or Jakarta E, how they've traditionally worked, it's been all about reflection, use of runtime proxies, and so forth. And Micronaut, instead of doing that, shifts all that work into the compiler. So when you start your app, it's already like configured and wired together and ready to go.
And that's what you mean by ahead of time compilation.
That's right. Yeah. So it essentially prepares your app during the compilation phase, so that when you start it up inside Lambda, for example, or inside a container, it starts up much quicker, and it uses a lot less memory because we don't have to scan the class path, we don't have to use reflection, and we don't have to do a lot of the processing that traditional frameworks do.
So smaller footprint, super important, faster startup time.
That's right,
equally critical.
And smaller distribution units as well, because like a Micronaut app is only like a 10 megabyte jar file. Which
and that's a complete jar file itself.
Yeah, and that's if you use an Uber jar approach, obviously if you use layering, that's a different thing. But if you package it into an Uber jar, it's only like 10 megabytes. If you compare that traditionally to like traditional stacks where you would end up with like a 50 megabyte WAR file, or that's a big difference in terms of how big your Docker image becomes and so forth. And it also has an impact because we do more work in the compiler. That means the runtime part of Micronaut is much smaller, much thinner, much more optimized, and that's critical. And I think that's a direction the industry is going in general. If you look at things like that have come after Micronaut, things like Quarkus, things like GraalVM native image, this kind of movement to create more intelligent compilers that allow the Java runtime part to be much thinner, leaner, and more efficient. I think that's a general industry direction that we're seeing right now.
So really leveraging the Java compilers, what it is best for,
right?
And kind of passing on that savings to the customers,
Absolutely.
so that their apps can be smaller, start faster.
Yeah.
And particularly as we discussed in the microservices world,
yeah.
because you have a multi-node cluster, potentially a Kubernetes cluster or whatever kind of cluster.
Absolutely.
Your app could be downloaded on any node at any point of time on demand.
Absolutely.
So you want that image size to be small and
as small as possible and boot fast. Yeah, and and it's also even if you're not using Kubernetes, even if you're using traditional cloud solutions like App Engine or Elastic Beanstalk or something like that, people are concerned about their overall cloud spend. With the resources being charged, based on how much memory your application uses or how much processing power. One of our customers for Micronaut is able to halve just how much they spend on cloud spend just by having an application that migrating from a framework that uses more memory to a framework that uses less memory and has the same overall characteristics as their existing tooling. So
exactly.
So that's really important.
So I presume it will also benefit not just the containers, but like a framework like AWS Lambda, for example.
For sure, yeah, and we have really nice Lambda integration. We actually worked with the AWS team at Amazon, the serverless container on the serverless container project, to build integration with Micronaut. So we have an implementation of the AWS serverless container project, so that you can write lambdas that look essentially like normal web applications, but can be deployed directly to Lambda. And because Micronaut does a lot of the initialization, optimizes a lot of the initialization, and you end up with faster cold starts, which serverless customers are really important to them. And taking that even further, we added integration. We added, for example, a AWS custom runtime that integrates GraalVM native image, so that you can pass your Micronaut application through GraalVM native image, produce a native image binary that runs in a custom Lambda runtime, and you get even faster startup time. So if you want to take it to that next level, so we've done a lot of work on Micronaut to optimize it for serverless and make it an efficient platform to build serverless applications.
Very cool. So you can get a faster runtime. It doesn't matter what platform you're running on.
Yeah.
But whether it's containers, whether it's Lambda, whether it's serverless, wherever you're running, you're just leveraging that integration and pushing it along.
Absolutely. I mean, Micronaut itself is really just a framework for building anything that has a static void main, any Java app really. We have folks internally that are using it to build Swing applications and JavaFX applications. So. Because it has a part that's like the dependency injection part, it has a part that's the aspect-oriented programming part, it has pieces of it that make sense in whatever application you're building.
Right.
And because they're fast and efficient and they load quickly and they're computed during the compilation phase, it makes a lot of sense for those applications. And we even have it running on Android, for example.
Right.
Which is
so
cool.
Now help me understand. This is like a Java application with annotations sprinkled throughout the code, which is basically what is doing the real trick for you.
Yeah, and so instead of if you think about how a traditional framework like Spring works or like Jakarta EE works, it's going to at runtime scan your classes or whatever, and then reflectively look at the annotations that are present on those classes using traditional Java reflection. So it'll look at hey, here's a method that has an @inject. I need to inject this component, or hey, here's another method that. So that kind of processing, if you do that at runtime, reflection, the usage of reflection results in increased memory consumption, because reflection in Java is essentially an all or nothing deal.
Yeah.
So if you ask for a reflection on one method, you get all the methods.
Right.
And then it's stored within the JVM in soft references. So with Micronaut, we don't use reflection at all. So we never touch the reflective data.
And that's where you save the cost right there.
And we save a lot of memory cost right there, just by eliminating all reflection and reflective data caches. But by providing the same more or less experience that you get from something like Spring or something like Jakarta EE. And in fact, because we've abstracted the annotation model such that it's all translated at compile time, we even support things like the official javax.inject TCK. We support the Spring annotations as well, because the annotation model is completely separate to the runtime model. So it's actually very flexible in how you construct your app. But it feels very comfortable, very familiar. If you're a Spring developer, for example, we have folks that, wow, this feels really very familiar to me. It's very experience. So we have a lot of folks that are coming over from those kind of frameworks, looking at Micronaut for improving efficiency, making their applications faster, use less memory, and so forth.
So you would either choose Spring or Jakarta EE or Quarkus or Micronaut, one of these frameworks.
Yeah, but we haven't eliminated the potential to, for example, one day support MicroProfile within Micronaut, because it's we've abstracted the whole like I mentioned, we've extracted the whole annotation processing part into the compiler. We can support new annotation sets such as JAX-RS or Spring, or because the processing is all done at compilation time.
Right.
So I've had discussions with the Quarkus guys and the MicroProfile guys about potentially in the future supporting it in Micronaut and so forth. So I don't think it's necessarily an either or deal. It could be just Micronaut becomes a lot further along the line another participant in that community.
Correct. Could be like a faster Jakarta EE or faster Spring, whatever.
Yeah, and we implement a lot of the specifications. I already mentioned we implement javax.inject. We have a partial implementation of javax.validation. The bean validation API without the reflection parts. So you see, that's one of the reasons.
You're selectively picking the APIs.
One of the reasons we didn't want to claim compatibility for the TCKs is because many of the TCKs say you must use reflection here, or you have to use this API that takes java.lang.reflect.method, and we didn't want to enforce reflection on our users when we have a better solution already.
Right.
So we implemented javax.validation, for example, bean validation partially, so that you can use the javax.validation annotations. But if you want to use the metadata API, which is like a separate thing, to introspect your classes, that part is not implemented. Because it requires reflection.
So I think instead of saying being not compatible, I would say it's an opinionated approach.
Yeah,
you're very, very picky about what you're going to take, because you don't want the users to be hurt at runtime.
Right, and also with the whole, we made a decision to abstract and not tie ourselves to a particular annotation programming model, like I mentioned before.
Right.
So you can use Spring annotations, you can use Micronaut annotations, and that proved to be the right decision. When you look at now the rename from JavaX to Jakarta. That's not going to be a problem for us, because we can just it's just
because it's all abstracted anyway.
Right, it's just another set of annotations that we compiled.
Right.
And because the processing done is in the compiler, it doesn't. For a framework that does the processing at runtime, they have to add checks.
Right.
Is this the JavaX annotation? Is this a Jakarta annotation? And add runtime overhead.
Yeah.
We don't have that issue because it's done at compilation time.
Got it. Now, what kind of tooling experience does Micronaut offer?
So in terms of tooling, because Micronaut is essentially just an annotation processor, which have broad adoption already, largely because of Android, but because of many reasons such as Lombok and so forth, and MapStruct. The tools already support it really well already. So Visual Studio Code, IntelliJ, and Eclipse all have support for annotation processes already.
These are usual Java developer tools that customers are used to, and they can use that as
right. So it's just a matter of configuring another annotation processor, and most IDEs support that automatically. Right. So they just detect, hey, here's an annotation processor.
They pick up a jar, they pick up the APT from that, and then
it just works. So there's no real tooling that you need for it. And for things like configuration, we actually, some tools, for example, support code completion of application.properties or that kind of thing. So we publish the same metadata format as Spring, and the IDEs just pick up the metadata and complete it because it's there. So
am I being exaggerating by saying that even the debugging experience is quite similar in that sense?
So the debugging experience, I would say, is even better because we don't use features such as the runtime generation of proxies or the runtime generation of bytecode generation or reflection. Those kind of features that traditional frameworks use, you end up with huge stack traces. Java.lang.reflect.invoke, like massive stack traces.
And I don't know what am I looking for.
Yeah, and you have to look through all this reflection, invocation, stack trace, and it becomes really cloudy. Because Micronaut doesn't use reflection, the stack traces are much shorter. That makes the debugging experience, a lot better.
Very localized.
Very localized.
Where the error is.
Literally, like for our aspect-oriented programming implementation, AOP, for example, It's like 5 stack frames between when you actually invoke the code and the interceptor being executed.
Right.
So it's a much smaller and more efficient implementation, and the savings we get from using direct method invocation reflect as well in the benchmarks and runtime performance and all sorts of things. The JIT is it's much easier for the JIT to optimize shorter stack traces than it is to optimize longer ones.
Sure.
So,
Yeah. What kind of distributions are created for a Micronaut application? Is it like a standard Java jar or? Yeah,
so it's like I said, Micronaut is just any application that has a public static void main. So it's literally a jar file. So how you end up actually shipping and packaging your Micronaut application is really down to you. You can use an Uber jar if you want, and have a runnable jar file.
So give me an idea, like if it's an Uber jar, typically if you use like a Spring application, the Uber jar is, at least for a hello world, is 50 megabytes straight up.
Yeah.
Without even thinking.
Yeah.
You do public static void main, hello world.
Yeah.
And you come with that baggage.
So that's one of the things we wanted to improve on. It's not creating a lighter experience is not just about eliminating reflection and so forth. That by moving more work into the compiler and doing more work at compilation time, we actually are able to create a thinner, smaller runtime. And the net effect of that is that the runtime in Micronaut, when you build a jar file, is only about 10, 11 megabyte. And you've got a workable application that has a whole bunch of features in it.
So it's literally 1/5 the size.
Yeah.
And that impacts throughout your microservices architecture, your Lambda, your serverless architecture, everywhere.
Your Docker image size, all that
the whole deal.
It has a big impact. And it also has an impact if you ever do consider to go the native route with something like RAL VM substrate, because the more bytecode you have, the bigger your jar file, the bigger the native image.
Right.
So with Micronaut, you actually produce a really small,
so
efficient
really
native image.
From there.
Cascades from everything.
Yeah.
So we have zero external dependencies. It's really a small, efficient application, and many parts of Micronaut are written with Micronaut itself. So, for example, Micronaut has its own HTTP client. And that has a lot of benefits. For example, when we integrate with something like Kubernetes for config maps, or we integrate with something like Console for distributed service discovery or configuration management, we have clients written in Micronaut that talk to those. And that helps as well to reduce your jar file size even smaller, because you're not pulling in a third-party HTTP client or something like that.
Because it is built into Micronaut.
It's built into Micronaut.
Yeah.
And that was one of the things we wanted to make right from the beginning with Micronaut is, a lot of the cloud integration with other frameworks has been a kind of bolt-on afterwards. So they were, frameworks created well before cloud native movement and so forth.
Yeah.
So they were kind of an add-on afterwards. We wanted to make sure that from the get-go, Micronaut was ready for cloud deployments. So it has things like, for example, automatic detection of whether you're running, what cloud environment you're running on. So if I deploy my application to AWS, for example, it will automatically know that, activate an environment that you're in AWS, which allows you to do things like have beans or classes that are active only in your
in that particular cloud.
In that particular cloud.
Yeah.
And same thing for GCP, the same thing for Azure. So we have automatic detection of the platform.
And the fact that this is standard Java, it can just go across whatever the Java distribution. So Java debugging, Java tooling, Java distribution, Java packaging, everything that you are aware of, because it's just an annotation processor, it just integrates seamlessly across the board.
Absolutely, yeah.
What are your future plans for Micronaut?
Well, we have a lot. At the moment, we're working on Micronaut Data, which is, we want, with Grails, we had Gorm, which was the database access toolkit.
Right.
And people love being able to do, have a domain class or an entity called book and do find by title and have these dynamic finders and so forth.
Right.
So we want, Micronaut on the other hand supports Java, it supports Kotlin, it supports Groovy, it supports a much broader set of languages. So we wanted to create something that allows that same kind of productivity for the data access layer, but without using many of the features that traditionally cause memory strain and so forth, dynamic proxies, bytecode generation and so forth. So with Micronaut Data, what we did was we actually moved the computation of the queries into the compiler itself.
And so once again into the compiler.
Once again, making your compiler more intelligent.
Yeah.
So when you have a method like find by title, it translates that at compilation time into your SQL or JPA-QL query. Select star from
as opposed to doing it at the runtime.
As opposed to having to do that computation.
You're not incurring that cost at runtime.
Yeah, you're not having to create caches again. You're not having to intercept the method call, create do the computation, create a cache, and add more processing power. So we can do that work in the compiler, and again create a leaner, smaller, more efficient runtime. And that's the whole thrust of Micronaut, creating a smaller runtime.
Fantastic, fantastic. Any places where you need help from the developers?
Oh, we're always looking for contributions. We've had already loads of contributions to Micronaut. It's been still a year for us. We're out to hit 3,000 stars on GitHub. So, but send us a PR, and we would love to.
Where would they go?
Well, we have our issue tracker, and there's a help wanted tag.
What's the website?
So github.com's Micronaut project, or actually it's probably easier to just go to micronaut.io.
And how do you spell Micronaut?
No,
I mean, we want to call it out for our
okay, so micro, M-I-C-R-O,
right.
And then naut, as in like astronaut, N-A-U-T.io. Head there, and from there you can head to the GitHub. We have a big GitHub link, and you can go to the source code and send us a PR. There's all the documentation available there, and check it out. And also my talk, my deep dive that I did yesterday, that's all available on YouTube as well in the Devoxx channel. So go to YouTube and search for Devoxx, and my talk is available there.
Very cool.
And check it out.
And since it's open source, it's very important that you contribute and you make it more successful. Open an issue, file a PR, use it, evangelize it, do whatever you want to do.
Don't be afraid. We love PRs, we love contributions, and we've already had, there's already 500 forks of Micronaut or something like that, and we've had so many PRs, so many contributions already, and we welcome more.
Fantastic. Thank you, Graeme.
Thank you very much.
All right, thank you very much. This is Arun Gupta signing off from here.